Hello everyone. In the previous lecture, we have understood what is Lagrange Interpolation Method. In this video, we will try to code the same method in MATLAB. If you haven't checked that video yet, then go to that video and please make an understanding of Lagrange Interpolation Method first so that you will not have any problem understanding the line of statement of these codes. Let us firstly write the Lagrange interpolation polynomial first, where we approximated the function f of x as phi of x, where it will be of the form a0 into y0 plus a1 into y1 plus a2 into y2 plus so on to an into yn, provided we are already given the tabulated form of the data points and we have seen the generalized ai value is x minus x0, x minus x1, so on to x minus xi minus 1 into x minus xi plus 1. What we have done here is we have skipped the value of xi while subtracting it from x and continued the same way until x minus xn, that is the last term, and this whole term is divided by replacing the x value by xi in the denominator, and rest all of the equation is same as the numerator. Without wasting any time, we will directly move to the MATLAB code, where firstly we will try to know the data points. For that we will use the variable x values to store the value of x, and using the input function to ask the user for the values of x in the form of a vector. Similarly, we will use the variable y values and input value to ask the user to enter the y values as vector again. After we have asked the user to enter these values, we will find the number of data points in either of the values, that is either x values or y values, because both of these vectors are going to be of the same length. Since we have to construct a polynomial, so we will use symbolic variable for constructing the polynomial, that is sy ms x. Let us initialize the Lagrangian polynomial to 0 using L underscore poly as a variable name for the Lagrangian polynomial, and then we will initialize an array for storing the corresponding ai value using L underscore values is equals to sym bracket zeros 1 comma n. Please note that here sym will ensure that the array is ready to store symbolic expressions which will be necessary in our code for constructing the Lagrangian polynomial. After that, we will start calculating the values of ai's. You can use the variable ai here to make the better understanding. as we have used the variable name ai while calculating the polynomial. Now we will start the loop from 1 till the number of variables we have. Then using the for loop again starting from 1 to n, and if the value of j will not be equals to I, then we have to calculate the value of a underscore I as a underscore I into variable x minus the x value at the corresponding j value, and we will divide this term by the corresponding x value of I minus the x value at j, and we will end this if condition, and this for loop will end also. Now understand that we are multiplying ai value to itself again, so we have to initialize the ai value as 1 first, and then we will store this value of ai in a values at the corresponding I value, and then we will accumulate this to the Lagrange polynomial with the help of L underscore poly is equals to L underscore polynomial plus the value of ai into the corresponding y value at this point, and then we will end this loop. Now let us firstly try to make an understanding of this loop first. For that, I will consider a very simple question where the x values will be 1, 2, 3 and y values will be 5, 15 and 31. And we know the Lagrangian polynomial will be phi of x is equals to x minus x1, x minus x2 whole divided by x naught minus x1, x naught minus x2 into y naught. Similarly, the rest of the terms will be, after substituting, the Lagrangian polynomial will be x minus 2 into x minus 3 whole divided by 1 minus 2, 1 minus 3 into 5. Considering this example, now we will take the loop. When this statement will run, the value of I will be 1. And from this example, we can see the value of n here is 3. And I have considered a underscore I as initially 1. Now, j will be initialized and the value of j will be 1. When the value of j will be updated as 2, now the if condition is satisfied because the value of I here is 1 and the current value of j is 2 and they both are not equal. Then we will update the value of a underscore I as 1 into x minus x value at the corresponding j value, which is x minus x value at j, and the value of j is 2. So the value will be this, x minus 2 will be in the numerator, and this whole term will be divided by x value at I minus x value at j. The value of I is 1 and it is 1 minus 2. and it will be simplified as minus of x minus 2. Now the current value of ai is updated as minus of x minus 2. Then the value of j will be updated as 3. Still the value of I and the value of j are not equal, so if condition is satisfied and value of a underscore I will be updated. The current value of a underscore I is minus of x minus 2 and it will be further multiplied by x minus x values at j, and the value of j is 3. So we are at the point this. It will be x minus 3 whole divided by x value at I, which is 1 minus 3 again. Then this value will be updated as x minus 2 into x minus 3 whole divided by 2, and we can see that this value of ai is same as this value. So when the value of I is 1, we have calculated the value of a naught, and when the value of I will be updated as 2, we will be calculating this value, which will be corresponding to a1, and when the value of I will be updated as 3, we will be calculating this value, which is the value of a2. So I hope the working of this loop is clear to you, and in this statement we have just updated the value of the current polynomial after multiplying each value of ai's with corresponding y values. Till now we have known the value of the Lagrangian polynomial, but this calculated value will be unsimplified version in terms of x, and to find out the simplified version we have to use the statement L underscore poly is equals to simplify this polynomial. After that we can use the printing statement display L poly. Till now this code will just directly print the Lagrangian polynomial with respect to the variable x, and in the previous video we have seen in the second question sometimes we are also asked to find the value of the predicted function at some given point. For that you can use the line of statements as x underscore p is equals to input enter the value of x at which to predict the function value. And the corresponding value of y will be equals to double substitute L underscore poly, which will be my Lagrangian polynomial, and the corresponding variable x, and to be interpreted value as p. And after that using a printing statement. I hope you have made an understanding of this code and each statement of this code is clear to you. Now we will directly move to the MATLAB screen and let us see how this code will work. We have used the same code we have discussed in the MATLAB code. Like we can see in statement 3 and 4 we have asked the user to enter the values of x and y's, and then in line number 7 we have tried to find out the number of data points we have already entered, and in that length we can use either the value of x values or the y values, because the length of the vector is going to be same. And since we have to construct a polynomial in some variable, so in statement number 10 we have used symbolic form of variable x. After that we have initialized the variables we are going to use. Then we use the for loop to find out the values of ai's and construct the polynomial. You can skip this commented part. And after that we have simplified the polynomial we have constructed from the for loop, and then we use the printing statement to print that polynomial in statement number 54. After we have known the polynomial, the next thing I have used in the code is to predict the values of the polynomials at any given point with the help of the statement number 57 and 58, and then I have used a printing statement to print the result. Let us try to run this code. In the command window, the first statement will be to enter the values of x as a vector. Since we have to enter the values of x as a vector, it will be like, I am using the question number 2 I have discussed in the previous video. If you want to check the manual solution of this question, please go and check that video. After entering the x value, the next statement that will print will be to enter the values of y's as a vector. After entering the values of y, the simplified Lagrangian polynomial will be printed, and the code will ask to enter the value of x at which we want to predict the function. And in question number 2, we were asked to find the value of f at point 3. So entering the value of x as 3, it will give the predicted value, which is 35, and it is same as the answer we have discussed in the previous video. Here are some practice questions for you all. Firstly, try to solve them manually, and then try to input these questions in the MATLAB code we have discussed and verify if your answer is correct or not. If you have found this video useful, don't forget to share it with your friends, and if you have any doubts, please let me know in the comment sections. Happy learning!